Pluto is a fascinating and mysterious celestial body that resides beyond Neptune within the Kuiper belt. While it was once regarded as the ninth planet in our solar system, its status was redefined in 2006 when it was officially reclassified as a dwarf planet. From the outset, Pluto seemed out of place. Its orbit intersects those of other planets, a behavior atypical for a planet. However, this fact has not lessened the intrigue surrounding this extraordinary object in space. As we look beyond Earth in our quest for life, Pluto stands out as an interesting and potentially promising candidate. Despite being traditionally considered inhospitable to life, recent discoveries, both on its surface and beneath its icy shell, have surpassed our expectations. Stunning images taken by the New Horizons spacecraft and the James Webb Space Telescope are reshaping our understanding of Pluto, revealing it to be much more than a mere dwarf planet. These findings have caught the attention of scientists because they do not conform to what was once believed to be true. As we delve deeper into Pluto's concealed mysteries, questions arise about the size of this overlooked world in comparison to Earth. Is Pluto really as small as 1/1000th, 1/10,000th, or even 1/1,000,000th of Earth's size? This inquiry prompts us to reconsider Pluto's true nature and scale in the grand cosmos. The theory of a subsurface ocean beneath Pluto's frozen exterior has gained traction thanks to the discovery of extensional fractures and the scarcity of significant craters in specific regions. These factors suggest more recent geological activity than previously anticipated. Although this theory is not new, it was first proposed in scientific papers in 2006, speculating on the potential for surface oceans on various celestial bodies beyond the gas giants, including Pluto. The arrival of NASA's New Horizons mission in 2015 provided unprecedented images and data that fueled further speculation. When the probe reached Pluto, it delivered the first close-up images of one of the most intriguing objects in our solar system, unveiling a surface marked by fissures, ice volcanoes, and a vast heart-shaped basin. These revelations have led some scientists to hypothesize that even more astonishing phenomena might be hidden beneath Pluto's surface. For instance, an analysis of images taken by New Horizons revealed an icy basin known as Plum, located almost directly opposite Pluto's largest moon, Charon. While this could be a mere coincidence, the likelihood is low. Only 5% of models suggest such a formation without any interaction between Pluto's surface and a subsurface ocean. When Pluto's nitrogen-rich atmosphere cooled and solidified, the nitrogen gas accumulated in the basin, generating a weight that caused Pluto to shift into its present alignment. The idea of a subsurface ocean has persisted over the years, and images of Pluto's far side have strengthened this hypothesis. Strong evidence of such an ocean has been found in the form of a feature known as chaotic terrain, a landscape marked by jagged cracks and disordered plains. This terrain is located on the opposite side of Pluto from the basin known as Sputnik Planitia. Scientists have observed similar phenomena on other bodies, such as Mars, Mercury, and Europa, one of Jupiter's moons. On those planets and moons, asteroid or comet impacts are thought to have generated seismic waves that converged on the far side, causing a similar chaotic terrain to that found on Pluto. Alden Denton, a graduate student in planetary geology at Purdue University, simulated how an asteroid impact could send shock waves through Pluto. The simulations yielded scientifically plausible results, suggesting that such a collision would only have been possible if Pluto had a liquid ocean beneath its surface. Oliver White, a planetary scientist at the SETI Institute in California, also conducted a geologic survey of Pluto, although he did not participate in the earlier study. While the features observed on Pluto's far side resemble those seen on other planets in the solar system, the low resolution of the images leaves some uncertainty. Nevertheless, there is a general consensus among scientists that Pluto displays unique geological features, including a large number of cracks on its far side, which raises the possibility of a hidden ocean beneath its surface and sheds light on its potential origin. Theories about Pluto's ocean have long suggested that it was once a liquid ocean that froze over due to the heat generated by radioactive decay in a rocky core. In this scenario, as the ice melted, it would have caused the surface to wrinkle, similar to the way wrinkles form on an apple left in the fridge. These wrinkles would have occurred due to the contraction of ice as it melted and expanded as it refroze, creating cracks in the surface. If this theory holds, the images from the New Horizons mission should show both older wrinkles and more recent cracks. However, the data from the mission primarily show cracks, suggesting that Pluto's surface oceans may have initially been liquid and then gradually frozen. Observations from New Horizons also revealed a giant rift running across Pluto's near side, extending from the North Pole to the South Pole. This feature, known as the Pluto Rift, doesn't suggest a sudden surface transformation but rather points to the continued expansion of a frozen ocean. The presence of water on Pluto is further supported by observations of water molecules on the planet's near side, which appear to contain organic molecules. While the presence of water on Pluto might seem unlikely, laboratory experiments have demonstrated that solar and cosmic radiation can produce complex organic compounds, including bases found in RNA and DNA. These findings strengthen the idea that Pluto could harbor organic molecules and potentially support life. Additionally, the probe's observations revealed a reddish band near Pluto's equator, possibly composed of organic material and corresponding to a region receiving more solar exposure and warmer temperatures. This discovery is significant because it indicates the presence of liquid water and organic molecules, two critical components for life. On the other hand, some UFO enthusiasts have suggested that Pluto could harbor artificial structures, pointing to anomalies seen in images of the dwarf planet, such as a smoky trail visible on its surface. While NASA attributes these anomalies to natural processes, some speculate that they might be evidence of extraterrestrial life on Pluto. Despite the exciting discoveries and the potential for hidden mysteries on Pluto, it's essential to remain cautious when interpreting such findings. While the evidence for a subsurface ocean and organic materials is intriguing, much of Pluto's environment remains harsh and inhospitable to life as we know it. Temperatures on the surface are incredibly cold, averaging around -375 degrees Fahrenheit -225 degrees Celsius, far too low for liquid water to exist in its normal state. Yet, the possibility that some form of liquid could exist beneath its icy shell, kept warm by internal heat from radioactive decay or tidal forces, makes Pluto's geophysical features all the more compelling. The notion of life beyond Earth has always fascinated scientists and the public alike, and with Pluto's surprising features, many are beginning to wonder whether there may be more to this dwarf planet than initially assumed. If Pluto's subsurface environment does harbor liquid water and organic molecules. As research into Pluto continues, scientists are eager to uncover more about its unique characteristics. The possibility of a subsurface ocean, combined with geological activity, suggests that Pluto may be more dynamic than previously thought. Future missions to Pluto and the Kuiper Belt could provide valuable insights into the dwarf planet's composition, internal structure, and potential for harboring life. One of the biggest challenges in exploring Pluto further is its vast distance from Earth. The New Horizons spacecraft, which provided our first detailed images and data, took nearly a decade to reach Pluto after its launch in 2006. With current propulsion technology, sending another probe to Pluto would require significant time and resources. However, advances in space travel, including nuclear-powered propulsion and improved communication systems, could shorten the journey and allow for more in-depth exploration. Another question that remains is whether Pluto has seasonal variations that impact its surface and atmosphere. Pluto follows an elliptical orbit around the Sun, which means its distance from the Sun varies significantly over time. This variation causes changes in its thin nitrogen-rich atmosphere, which can freeze onto the surface as Pluto moves farther from the Sun and sublimate back into gas as it gets closer. Understanding these atmospheric cycles could help scientists learn more about how celestial bodies in the outer solar system evolve over time. Additionally, Pluto's interaction with its largest moon, Charon, presents another area of interest. Unlike most planetary systems where moons orbit their planets, Pluto and Charon are tidally locked to each other, meaning they always show the same face to one another. This unusual relationship has led to speculation about how their gravitational interactions might influence geological activity on Pluto. Some theories suggest that Charon's gravitational pull may contribute to the formation of surface features like cracks and fissures. Beyond Pluto, the Kuiper Belt holds many other intriguing objects that could further our understanding of the early solar system. Some of these distant worlds may share characteristics with Pluto, such as icy surfaces, potential subsurface oceans, or even thin atmospheres. Studying these bodies could provide context for Pluto's formation and evolution, helping scientists determine whether it is unique or part of a broader class of icy dwarf planets. Despite its classification as a dwarf planet, Pluto remains one of the most captivating objects in our solar system. Whether it harbors a subsurface ocean, experiences geological activity, or even holds the chemical building blocks for life, Pluto challenges our understanding of what it means to be a planet. As technology advances and space exploration continues, future missions may unlock even more secrets hidden beneath Pluto's icy surface, offering a deeper glimpse into the mysteries of the outer solar system. For now, Pluto stands as a testament to the ever-evolving nature of scientific discovery, reminding us that even the most distant and overlooked worlds can surprise us in profound ways. Its characteristics and uncovering more about its origins challenge the idea that what was once considered a distant, cold, and lifeless body could potentially house organic materials or even an ocean beneath its surface. This challenges our preconceptions about habitability in extreme environments. It also opens up new possibilities for astrobiology, suggesting that life could potentially exist in places once thought to be too inhospitable. As technology advances and more missions like New Horizons continue to provide detailed observations, our understanding of Pluto and the potential for life in the outer reaches of our solar system will undoubtedly evolve. Whether it's the intriguing possibility of a subsurface ocean or the detection of organic molecules, Pluto remains a focal point for future research and discovery. Its mysterious and enigmatic nature continues to captivate scientists, and as we gather more data, Pluto may one day reveal even more secrets that could change the way we think about life beyond Earth. In conclusion, Pluto's transformation from a planet to a dwarf planet has not diminished its allure or its potential as a subject of scientific exploration. The discoveries made thus far, particularly regarding its geophysical features, organic molecules, and the possibility of an ocean beneath its surface, suggest that there is much more to this distant world than we once thought. As we continue to explore the far reaches of our solar system, Pluto's role in the search for life and its continued scientific importance is only just beginning to be understood. If you found this information interesting, don't forget to like, share, and subscribe for more updates on Pluto, the search for life in the cosmos, and other fascinating discoveries in the universe. Thank you for following along, and I look forward to bringing you more insights in the future. Pluto's continued allure for scientists and space enthusiasts alike stems from the many unanswered questions surrounding its existence. The dwarf planet's distance from the Sun, coupled with its unique characteristics, makes it a prime candidate for future exploration. Despite its classification as a dwarf planet, Pluto's features suggest an active world with a complicated and potentially dynamic history. The images and data from New Horizons have unveiled unexpected geological activity and surface features that seem to challenge the conventional understanding of how such a distant, small object could still harbor signs of activity. One particularly intriguing aspect of Pluto is its internal heat. Unlike what was originally expected, the heat generated within Pluto might be enough to sustain a subsurface ocean or, at the very least, allow for geological processes to occur on a planet so far from the Sun. This heat could come from the decay of radioactive elements deep within Pluto's interior, or it could be a result of tidal flexing, gravitational interactions with Pluto's large moon, Charon, causing internal stresses. Either way, this internal warmth could be crucial for maintaining liquid water beneath its icy shell, potentially allowing for chemical processes that might support life in some form, even if in a radically different manner than on Earth. The existence of such an ocean raises intriguing questions about the possibilities for life in the outer solar system. While the cold temperatures on the surface of Pluto make the idea of life as we know it seem impossible, life in extreme environments elsewhere on Earth has demonstrated that organisms can survive in even the harshest conditions. The discovery of extremophiles, organisms living in boiling hot springs, acidic environments, or under extreme pressure, has expanded the understanding of what constitutes a habitable environment. If Pluto's ocean is indeed liquid and contains the right chemical elements, it may harbor the simplest forms of life, perhaps in a dormant or microbial state. Further studies on Pluto's geology have shown evidence of active surface processes, including cryovolcanism. This type of volcanic activity is not fueled by molten rock but rather by the eruption of water, ammonia, and methane ices. This cryovolcanic activity could play a role in replenishing Pluto's surface, possibly cycling nutrients and organic materials into the subsurface ocean. It's a fascinating possibility, suggesting that Pluto, despite its frigid temperatures and distance from the Sun, could be a dynamic and ever-changing world. In addition to its geological features, Pluto's atmosphere also holds mysteries that continue to intrigue scientists. The thin atmosphere of Pluto is primarily composed of nitrogen, with traces of methane and carbon monoxide. This atmosphere undergoes seasonal changes due to the dwarf planet's elliptical orbit, which brings it closer to the Sun at certain points and farther away at others. These variations result in changes in temperature and atmospheric pressure that influence the behavior of gases and ices on Pluto's surface. The dynamic nature of Pluto's atmosphere, along with its unusual reddish-colored equatorial band, suggests that it could be a more complex and active world than previously thought. Pluto's distant orbit and eccentricity add another layer of complexity to understanding its role in the solar system. The interaction between Pluto and the Kuiper Belt, a region populated by icy bodies and dwarf planets, plays an essential role in shaping the environment around Pluto. The Kuiper Belt is a repository of ancient material, and studying Pluto offers a glimpse into the early conditions of the solar system. As the farthest known object in the Kuiper belt to be visited by a spacecraft, Pluto is a critical piece in understanding the formation and evolution of planetary bodies in the outer solar system. One key aspect of Pluto's potential for supporting life is the possibility of a dynamic subsurface ocean. The discovery of organic molecules on its surface strengthens the hypothesis that Pluto could be home to a kind of biochemical cycle. These molecules, which form the foundation for life on Earth, may suggest that Pluto's surface chemistry could be linked to processes that might support microbial life, even in the absence of sunlight. If liquid water is present beneath the ice and is capable of interacting with organic molecules, it's conceivable that Pluto could support forms of life, though they may be vastly different from those we are familiar with. Future missions to Pluto and the Kuiper belt could provide deeper insights into these mysteries. While New Horizons offered a groundbreaking first look at Pluto, a follow-up mission with an orbiter or lander could reveal much more about its surface composition, internal structure, and potential for hosting a subsurface ocean. Advancements in technology may one day allow us to drill through Pluto's icy shell and directly investigate what lies beneath, much like proposed missions to explore Jupiter's moon Europa or Saturn's moon Enceladus. The presence of organic molecules and the possibility of liquid water, even in such an extreme environment, fuel the ongoing debate about the necessary conditions for life. If Pluto does harbor a subsurface ocean, the interactions between water, rock, and organic compounds could create a chemical environment suitable for life, albeit in a form vastly different from what we know on Earth. This raises profound questions about how life might emerge and adapt in the most unexpected corners of our solar system. Beyond the scientific implications, Pluto's continued exploration has broader significance for planetary science. It challenges long-standing assumptions about where active geological processes can occur and how planetary bodies evolve over billions of years. The discovery of cryovolcanism, surface renewal, and a dynamic atmosphere on Pluto suggests that even distant, icy worlds can remain geologically active long after their formation. This realization extends beyond Pluto, encouraging scientists to reconsider other seemingly inert bodies in the outer solar system as potential sites of scientific interest. Additionally, Pluto's unique relationship with the Kuiper belt offers valuable clues about the history of our solar system. The Kuiper belt is believed to contain some of the most pristine remnants of the early solar system, objects that have remained largely unchanged since the time of planetary formation. Studying Pluto in this context helps scientists understand how planets and other celestial bodies formed and evolved in the cold, distant reaches of our cosmic neighborhood. As future space missions develop, interest in returning to Pluto remains strong. Some proposed concepts include a Pluto orbiter that could spend years studying the dwarf planet in detail, mapping its surface, monitoring its atmosphere, and possibly identifying regions where further exploration would be most fruitful. Other ideas involve sending landers or even submersible probes that could one day explore Pluto's subsurface ocean, if it exists. Ultimately, Pluto serves as a reminder that the solar system is far more dynamic and complex than we once imagined. What was once dismissed as a cold, inactive world is now recognized as a fascinating and evolving planetary body. Its potential to harbor organic chemistry, its surprising geological activity, and its connection to the Kuiper belt ensure that it will remain an object of scientific intrigue for decades to come. As we push the boundaries of exploration, Pluto exemplifies why space research is so essential. Every new discovery reshapes our understanding of the cosmos and our place within it. The quest to understand Pluto is more than just a study of a distant dwarf planet, it is a step toward answering one of humanity's greatest questions: are we alone in the universe? For now, Pluto remains a world of mystery and discovery, waiting for the next generation of explorers to unlock its secrets.